Hi friends, welcome to TechieMit. So good to see you after a long time. So in the last past month I was a bit busy, so I couldn't upload any videos. But continuing to our legacy of uploading quality videos, today I'm going to be new video on Semaphore in Java. So let's go for it. So before deep diving into the video, to keep liking, commenting, and subscribing to TechieMit. So let's keep a dive into the semaphore in Java. So yeah, basically semaphore is like you can consider it as a synchronization mechanism or a tool used to access shared resource in concurrent programming. Because if you remember all the videos that were related to concurrency, like reentrant lock, prior to that, to support the concepts, they were all concurrent related series that were related. They were all related to concurrent programming, and so synchronization. And to enhance it, there's a tool called as Semaphore. So basically, what it does, it's like remember there is a critical section of code or like access region means only some specific thread might allow to access, or a specific thread or set of threads might allow to access the shared resource simultaneously. So that is done with the help of Semaphore. That is done with the help of Semaphore. It basically restricts the number of threads that can access shared resource simultaneously at the same time. Basically, it's a non-negative variable that is shared among the threads known as counter. So to access the shared critical section or the shared resource, the semaphore introduces a counter. Basically, it's a non-negative or a positive integer to say to access the semaphore. So it's like it sets some non-negative like 0 and above values. It set. So to go into details, when a thread acquires a permit, the semaphore count decreases. So basically, when a thread acquires a permit to enter into the critical section, the semaphore count is decreased because there was one slot and it's now reduced to 0, or like any further down count. 2 there was 1, so the counter decreases and the permit is acquired by the thread. And also, when a permit is released, so basically, its work is done from of the critical section. It releases similar to the permit, and the counter increase, semaphore counter increases. If the counter value is 0, access to the shared resource provided is denied. And if the counter value is greater than 0, the access to the shared resource is provided. Simple. Because if there is 0, means that there is no shared resource that can be shared or enter into the critical section. So no further permits can be given. Only permits can be given when there are one or any above non-negative integer value. In that case, permits can be given. So the semaphore count increases, and we will see the detail into that how this happened. So this was the introduction. Now we will see into the types. So basically, we are classified into 4 different types. Binary semaphore allows only one thread to access the shared resource, so similar to like a lock, reentrant lock, as you said. So allow only one thread to access the shared resource in the synchronization, using the synchronized mechanism. And also there are counting semaphore, means there are a set of or a set of number of thread that can access the shared resource simultaneously. Then in the case of counting semaphore, that is if only binary is 1 0, that is only one thread, and counting semaphore like a bunch of thread or set of threads they may access the resource simultaneously. Similarly, we have bounded semaphore. That it means there is a upper limit, like some upper limit boundary that you can set. In that case, we can use bounded semaphores. Upper value upper value denotes how many signals it can have. So like there might be some 10, 20, 30, 40, 50. Like how many there is some threshold set. So using bounded semaphore, you can set it. Similarly, we have time semaphore. allowing to run for a specific amount of time. After that specific timer resets, it releases all the permits. So like it's like you can say like there is like 20 minutes, 15 minutes in which it might allow access to all the waiting threads to access the shared resource simultaneously, and after that it releases all the permits. Means synchronization only, like it might be the case like a bunch of thread that might access the time semaphore, and after the specific time is over, like 10 seconds, 20 seconds, and it may allow all the like waiting threads like 10, 20, like n number of threads that might be waiting. They may access the shared resource using the time semaphore. So, and after once the timer is reset and all, it releases all the permits and that were acquired by the threads. So yeah, only so according to scenario, you have to consider that which semaphore can be used when. So if there is one thread, you can go for binary. They're counting semaphore for a bunch of threads. You can go for either counting or time semaphore based on the requirement. If it's a time bound, you should prefer time semaphore. And if time constraint is not there, you can go for counting semaphore. And bounded semaphore is like there is some upper limit value set. In that case, you can use the bounded semaphore. To go further, basically, what is the purpose of using semaphore? As you like knowing that already there are some uh, synchronization tool like using synchronization block, synchronization method, re-enter lock that already is in lock interface, and other synchronization are also there. So, what is the specific purpose of using semaphore? So synchronization is one of the key concepts. Semaphores help in coordinating the actions of multiple threads, ensuring that they don't interfere with each other when accessing the shared data or resources. This helps to prevent data corruption and maintain consistency in data. Yeah, because if, as you know, there is a dirty read or dirty write problem. If they multiple, they try to access the thread, and the other thread might see the corrupted data. Means consistency is not maintained in such cases. So synchronization is necessary to ensure that only data is remaining consistent and is not corrupted, and to ensure the data integrity. Synchronization is used, and it serves the purpose of mutual exclusion by allowing one thread or like only some thread to access the credential section at a time. Over here, there can be exclusion can be for one thread or multiple thread, as you are saying there, depending on the type of semaphore that you're using, be it either counting, be either with a time semaphore or binary semaphore or bounded semaphore. Yeah. So signaling, yeah, this is specific case of bounded semaphore. Semaphores internally use signaling where one thread can signal another thread to proceed once a certain condition is met. This allows the threads to coordinate their activities and avoiding deadlocks. Yeah. So deadlocks is something that two or more threads are waiting for each other lock to be released, and none of the thread releases the lock, which ultimately results in deadlock, and it results in starvation. So to the thread, what they do inter-process communication by signaling. By signaling, they communicate with each other once a certain condition is met, and they accordingly plan the activities the thread internally. Uh, that is the like specialty or characteristic of Semaphore you can take into consideration. And resource management, yeah, it can be used in basically database connections, thread pools, where like only there are like a set of connections and only one connection you want to allow at the same time, and like thread pool is there, and in the database connection only one set of database connection you want to set active, and like there are a set of threads. In such cases you can certainly use semaphores. And thread pool is, yeah, as you consider thread pool in multi-threading related concepts, a real case scenario that might be used. In that case also you're using for the efficient resource management uh, that can be achieved through semaphores. So let's see further. So there are some important methods related to it. So basically, the foremost important thing is that it belongs to the java.util.concurrent package. Semaphore belongs to that package, and some important methods are like acquire, waits for permit if none is available, So basically, if a thread wants to acquire the shared resource or the critical section, it will invoke the acquire method first. And if there is like previously executed thread and its execution is done, it will invoke the release method. It releases the permit, allowing the other thread to access. So that it will allow the waiting thread to access the shared resource. After that, we have try acquire. So attempts to acquire a permit if available immediately. So like Boolean try acquire, it sees if there is permit. If there is permit, it will return as true. If there is no permit, it will return as false. So try acquire attempts to acquire a permit if immediately, like it's continuously checking if it's available or not. Try acquire. If it's returned true, it's immediately it acquires the critical section or shared resource. After that, we have available permits. So what it's basically integer method. It returns the current number of permits available in the Semaphore. In Semaphore region is there, and like there may like 10 permits, 20 permits. The number of count or the head count that is written by the available permits methods. And is fair is the returns true with the Semaphore has fairness set to true. So fairness is some specific characteristics if it's set to true, and it is a boolean is fair method. It returns true. The returns false. And after that, we have reduced permits introduction. Shrinks the number of available permits by the indicated reduction. Yeah. So reduced permit introduction means so if in a chunk or like a batch of threads are need to execute and they all execute at once, and so the headcount will reduce at once. So it reduces the permits. So from 40 it will go to 30 or 20, and like on depending on how many batches it's allowed to execute. And so you're using the reduced permits, you can achieve that. So these were like some of the important methods. Like acquire is for acquiring the thread, release for releasing, try acquire, available permits is fair, reduce permits. Let's go further. Now seeing at the advantages and limitations. So basically the main advantage is that efficient resource utilization. So when memory management is developing an application where memory management efficient utilization memory management needs to be done, then Semaphore needs to be taken into consideration. And also it helps in preventing resource starvation, because each thread is guaranteed to execute and achieve the critical sections and to execute it work. So it will not happen, and that some threads are always starved of its execution. So that is two main advantages of the resource management. Efficiently can be done, and the resource starvation. So also there are some like there are two aspects of each and every side. So there are some limitations also. So coming to that, having said that, it is like it's complex to debug in large applications, because if you make it a point to implement a very large complex application, it's and like any like a specific semaphore you try to implement for a complex system, then debugging at a specific like a level, it might be difficult and possible deadlocks if not used correctly. Yeah, because you have to maintain. Yeah, to maintain accuracy in implement, because if you allow like more, the number of threads all the permits are larger than the number of acquire, it may deadlocks. And like if you efficiently implement the semaphores, so you should be have the like prior knowledge of having the resource and how it algorithm needs to be in place, and while using semaphores you need to take into consideration. So this video was all about Semaphore and introduction, in which we saw from the beginning the various utilization of Semaphore. And do keep liking, subscribing, #TechieMit. So stay tuned. More to come on multi-threading related series. There's at least 5-6 videos more. See you then. Bye.